Hi everybody, this is Ms. Brown and this is video 6 on creating equations. The essential question that we're going to be covering today is how do scientists make equations and how can I check that an equation makes sense? There are only 6 main equations that you are going to be using in physics this year. Each of these is really powerful and can be used to solve lots of different types of problems. We can rearrange them to solve for different variables in the equation. One of the big misconceptions about equations such as these is that really smart scientists just came up with them, had kind of a light bulb moment, and the equation just came to them. In reality, scientists built these equations by looking at relationships between the variables within them. So what you're going to learn how to do in this class is how to build an equation in the same way that these scientists did. The reason why we care is that equations such as these allow us to predict the future and explain the past, and basically to understand our world and our universe better. In this class, equations are always given to you on tests, but you can always just build them again if you needed to. So the first step in building an equation is to identify the dependent variable and all the independent variables that it depends on. So for example, let's say it's the first day of school and you want to make an equation to scientifically calculate the niceness of each of your teachers. So you're going to call this variable n, uppercase N. And you decide that n depends on only 2 other variables. The first is the amount of candy that the teacher gives out. This is variable c. And the amount of homework that the teacher assigns, variable h. So n, which is niceness, is the dependent variable, and c and h are the independent variables. The next step in building an equation is to figure out what kind of mathematical relationship each of the independent variables has with the dependent variable. So in our example of teacher niceness, when the amount of candy given to students goes up, the niceness of the teacher also goes up. So there must be a linear relationship between C and N. In addition, when the amount of homework a teacher assigns goes up, you're probably thinking that the niceness of the teacher is going down. So there must be an inverse relationship between H and N, homework and niceness. In our third step of building the equation, we put the dependent variable on one side of the equal sign. Any independent variables with linear relationships go on the numerator of the other side, and any with inverse relationships go on the denominator on the other side, which is the bottom. So why does this work? So we're looking at the linear relationship first. The values on each side of an equation must always stay balanced. So if we make C bigger without changing H on the bottom, this means that N must also get bigger too. So there is a linear relationship between N and C. If we double the amount of candy that a teacher gives out, we are doubling their niceness as well. Also, if we have the amount of candy that a teacher gives out, we are cutting in half how nice they are. So let's look at how this works for our inverse relationship. So again, the values on each side of an equation must always stay balanced. If we make H bigger without changing C, so H gets bigger, This means niceness must get smaller. So there's an inverse relationship between H and N, between the amount of homework and the niceness of the teacher. If your teacher's giving you lots and lots of homework, you're probably not going to think they're very nice. Their niceness level is going to go down in your eyes. So before we summarize, let's quickly revisit our essential question that we started with. How do scientists make equations, and how can I check that an equation makes sense? So what we want you to do right now is to write a summary in your notes over what we've talked about in this video. Remember to cover the steps of identifying the variables, figuring out the mathematical relationships between them, building your equation, and then checking this equation by changing the independent variables by keeping the equation balanced and making sure the relationships are correct.